Hello everyone, this is video 9.4 and we're going to be looking at solving algebra word problems with strip diagrams and with algebra, which is kind of a weird name because of course we're going to be solving algebra word problems with algebra, but I think when you see what's going on, it'll make some degree more of sense. At least I hope so. We're going to be introducing these strip diagrams. They're not going to operate really a lot differently than the algebra tiles. Examples that we looked at in the previous video. So it's just a different model, a different way of thinking about working with this type of problem. And so very similar to the area model and rectangular models that we looked at in fractions, base 10 block models versus area models that we looked at before with numbers. This is another model that we can use to understand this type of problem. So let's get started. Okay, so I'm going to look at two examples, and in the course of doing these two examples, hopefully this method will make some degree of sense. So there's the example on this slide, and then an example on the next slide. Rather than go into a lot of theory, there's not a lot of definitions really. We need to define what the strip model looks like, but once we draw the first one, that should make some degree of sense. A lot of this is going to be using ideas and approaches that we've used before, so there's nothing really all that much new to this after we've defined the strip model. We're going to be just using old things in somewhat new ways. I do want to point out that this problem we could solve using an equation. So I'm sure some of you are going to read this problem and want to set up an equation 3x plus 6 equals 30 and then subtract the 6 divided by 3. So that method certainly works, and we could also solve this using the base 10 blocks that we looked at in the previous video. 6 units and then 3 variable tiles, 3 x's or 3 m's or whatever variable you want to use, and then that equals 3 longs. Remove the 6 from each side, partition into 3 equal parts. And that method works as well. So it's not that this method is any better or worse than any other methods. I think obviously the symbolic method we would want to use toward the end. That is the abstraction. That's where we want to eventually build to. And so I've hopefully established this point over the course of this semester that we want to build this concrete model first before we move into that abstraction. So let's set this model up. You can see sort of how we use this model. So it's a strip model. So I need a strip. And so we're going to think of this like a little piece of paper, right? And I'm going to mark off $6 here. And this is the $6 that Alice started off with. I'm going to break the rest of it into 3 equal parts. And so this is how much she saved the first month, the second month, and the third month. And we know that this is the same amount each month. So we'll call this M for money, or even M for month. So we've got these 3 M's, and we know this total amount is $30. So this is how we're going to start off with our strip diagram, and you can kind of see the equation that we have because we've got the strip sort of by its area, the 6 plus the M plus the M plus the M, but also by this length of 30. So the equation that is implicit to this is 6 plus 3M equals 30. And it's a little weird because we're talking about area, the 6 and the 3 M's, and then the length, which are really 2 different dimensions. So the idea that we're saying that they're equal to each other is a little strange. If it makes you feel a little bit better about it, you could say that this has a height of 1. So then the area and the length, sort of work in some capacity, even though the dimensions are off. But it's either here nor there. This is really just another way of drawing a double number line. We could, everything that we're doing in this section, we could also do with a double number line. And then we're comparing linear to linear, which on a certain level works a little bit better. But this is what we're comparing here. The 6 plus 3 M's equals this 30. So now if this length is 30, then I also know that this length has to be 24. because I'm removing this 6 from the 30. And so this is the equivalent algebraically of subtracting that 6 from both sides, of removing 6 from the left-hand side and the right-hand side. But I'm just talking about it in terms of length. And so now I have these 3 m's, and I have to break these 3 m's into 3 equal parts so that the sum is $24. And so I know this is going to break into $8 each. And so I see now that m and 8 are equal. So I get my solution here that m equals $8. Again, if you were to write out, so now this is 3m equals 24, and then we're dividing by 3, and so m equals 8. So you can see that what we're doing in the strip model is not any different than what we would do algebraically, solving it using an equation. It's just making it a little bit more concrete and making it a little bit more tangible for students to work with. It makes it more explicit what's happening in the solution of this equation. So it's not really any different. It's just a different representation that makes it a little bit more visible to students what's going on. So we have another problem here. Alice and Bob are a combined 26 years old. Bob is 2 years older than Alice. How old are each of them? So a couple of different ways we could set up this model, and I'll go through sort of both of them here. One way would be to have them stacked vertically like this. And so this is Alice's age, and this is Bob. And so Alice is X, and Bob is X plus 2. So he's 2 years older. And we know that their combined age is 26. So if we were to remove that 2, then we know that their combined age is 24. So if that total to begin with is 26, removing the 2 means that total then would be 24. And so now we have to partition this 24 over these two groups. And so we see that each of these x's would be 12. So this is one way using the x and the x plus 2 sort of stacked vertically. We could also do it horizontally, which is maybe a little bit more in line with what we saw in the previous example. So I'm going to put my 2 here. This splits into x and x. I can see this is Alice's age. I can see this is Bob's age. So Alice is x, Bob is x plus 2, and now I know this whole length is 26 years. So similar to before, I can take off that 2. And so now this would be 24 years, and then breaking that in half, again, I get x equals 12 for the 2 ages. Now, one thing to keep in mind, a mistake that a lot of students will make with this, is that they'll just write x equals 12. And if we go back and look at the actual question, it's asking how old for each of them. And so we can see Alice here is 12 years old. And then Bob is 2 years older. So Bob is the 12 and the 2. So Bob is 14 years. And so we can check the original problem and make sure that everything checks out. So they're combined 26 years. That's correct. 12 and 14 makes 26. So they're the correct combined age. And then Bob is 2 years older. So Bob is 14, Alice is 12. So both these, both the criteria from the problem check out. So for your checkpoint, I want you to go back and look at some of the ways that we use strip models with fractions, because this problem is going to draw from that a little bit more than the other two. So Charlie has 30 cookies. She ate 1/5 of them. Then she gave half of what was left to her friends. How many cookies did she have left? So again, you can solve this by other methods, but I want you to really focus on being able to explain this using the strip model that we've looked at in this section. As always, if you have any questions about this problem or anything from this section, please let me know. All right, thank you.